as participants are aware about Dr. Ajay Kumar Chauhan, sir. So we are directly giving the charge to start the session. Meanwhile, respondents, please, participants, please mute your, please check that you would be mute so that the session will run accordingly. And I have shared the data which is being shared by Ajay sir on your WhatsApp number, and shortly it will come on your email ID. So please use those data as sir will direct. Over to you, sir. Thank you.
Over to you. Okay. So, okay, good afternoon to all. And in morning session, I discussed about the unobserved heterogeneity invariances. So this lecture is also the extension of that. But the method is different. The topic which is given to me is predicted oriented segmentation. So let me show you the basic of that, and then we will discuss a case study. So I am sharing my screen. Yeah, so I hope you can see the screen. So there is a paper, the POS, the author write one paper on this, and with the help of this paper, I just want to explain something. This paper is known as Baker. So people quote this paper as a Baker 2000, I think 15. Yeah, the paper is published in 2000 something. And this paper is available on the ResearchGate. I can also share. Otherwise, this paper is easily available. So the topic of this paper is discovering unobserved heterogeneity in SAM models to avert validity threats. Right. So this is the name of the paper. So Ringle is also the co-author of that. So who designed the PLS software. Now, if you see these all yellow marked lines, just a few lines which explain the background of this topic. Given the, just see this, given the complexity of social and behavioral science, behavioral phenomena, one of the problems that we have is heterogeneity is likely to exist in the sample used. So when you conduct a research, the basic problem of that paper, of the sample, is heterogeneity, is the presence of heterogeneity in the samples. In order to explain this heterogeneity, the routine method is to add observed heterogeneity by introducing the moderators. So normally we show that whether the model is different for the male, different for female, different for different demographic profile. This is the common phenomena that most of the researchers do. But the problem is that they have not examined. So I just mark this line. But they have not examined how observed heterogeneity may affect their finding. So this is the key sentence behind this topic. The researchers do not examine how the observed heterogeneity affect their finding. That is very important, right? And this is actually the problem, that what heterogeneity will do. So they will increases the type 1 and type 2 error, and your conclusion may not be valid. misleading conclusions. So this is the problem. So some they also tell you that the while method to uncover unobserved heterogeneity are covariance based SM are relatively advanced. The method for partial PLS path model are limited and have relied on extension of multiple regression, Physics and other measures. So they proposed a new method. No, see this. They proposed a new method. The method is known as POS, prediction oriented segmentation. POS, prediction oriented segmentation. Now, what is the meaning of prediction oriented segmentation? We know that the every model in PLS or SAM, especially in PLS, have two properties. Number one, that is known as explanatory power. So we know that the explanatory power is measured by R square and the F square. Normally, we check the F square and the R square of the dependent and independent variables. R square is calculated for the dependent variable and F square is calculated for the independent variables. And they will tell you whether your model is having good explanatory power or not. So in normal sense, the R square should be greater than 50%. And if it is less than 50%, then model is not considered to be very good. So minimum expectation of R square is 50%. So we can say that the explanatory power is good. Similarly, F square value is calculated for the independent variables. The F square value tell you about the effect sizes, whether the effect sizes is low, mid, moderate, and high, and the cutoff values are 0.2, 0.35, and 0.5. No, 0.2, 0.15, and 0.35. These are the effect sizes of the PLS model. And any F square more than 0.35 is considered to be the best. Okay. So this is the measure of prediction. Number one, explanatory power. The second measure of prediction is predictive power, or in PLS we call it predictive relevance. So for predictive relevance, normally we calculate the chi-square, Q square, and there are two types of Q square, the capital Q square and the small q square. And capital Q square is calculated for the dependent variable, and the small q square is calculated for the independent variables. So this method is based on the prediction of the model. So we are doing the segmentation in such a way. If you remember, the segmentation is done in clustering. Also, we also do this segmentation in algorithm, algorithmic schedule, and that is known as hierarchical clustering. We also do the clustering in the k-mean clustering, and here we are also doing the clustering, but on the basis of the prediction of the model. So this method is known as prediction oriented segmentation. The method of segmentation which is based on maximizing the prediction of the model, prediction of the dependent variable. So this is the concept of POS. And in popular language, it is known as PLS POS. Okay. So now how this method is better than Physics method? So Physics method we have done in the previous session. Now the question is that how this method is better than Physics method. The Physics method is known as finite mixture method and based on the regression. However, so you can see that this method PLS, it overcomes the limitations of Physics PLS and other distance measured methods and conduct extensive simulation to evaluate the ability of PLS POS and Physics PLS to uncover unobserved heterogeneity in both structural and management models. So the author claimed that Both PLS and both POS and FIMIX are good method, but FIMIX is not a good method for the formative construct. So these two methods are very good in discovering the unobserved heterogeneity in structural models when the model are reflective, when the constructs are reflective. So both the methods are very, very good if your model is a reflective model, but in case if your model is having the formative constructs, then FIMIX will not work. FIMIX is not considered to be a good method. So what happens when your model is having the formative construct? In that case, you have to go for PLS POS method. So the author mentioned that the PLS POS also perform well in discovering unobserved heterogeneity in formative measures. So the line is very, very important line. Our results show that both PLS POS and FIMIX PLS perform well in discovering unobserved heterogeneity in a structural path where the measures are reflective. And that POS method also means in addition to the FIMIX, this method is also performing very good in case of formative measures. So this is one of the problem that we have in the FIMIX. Okay, now that is the proposed different thing. So if you see graph, this graph is significant to compare the different models. Now in the first graph, you can see that all the three black. If you calculate the impact of perceived usefulness on the intention to use, beta is found to be zero point 0.4. Similarly, if you calculate the impact of perceived ease of use on perceived usefulness, the beta is 0.3 and this 4. Now this data is the POS is applied on this data set, and we found that if you run the same model on two different groups, the beta changes like that. This is 0.74, this is 0.7, and this is 0.1. So you can see that there is a significant difference in the beta if you run in segment 1 and if you run in segment 2. Now just see these two segments and tell me what is the problem in this segment. So have you seen any problem in these segments? The basic problem in this segment is that one of the hypotheses is rejected. One of the alternate hypotheses is rejected in the first case and accepted in second case. The first hypothesis is accepted in first case and rejected in second case. So there's a total difference of path coefficient between the two models. So both the models in segment 1 and segment 2, actually model is same but the segments are different. If you apply the model in segment 1 and segment 2, the results are found to be different. So the question is that why it is happening, why this difference is happening, and how to make conclusion in such a case. How to make conclusion in such a case. Okay, that is the problem of unobserved heterogeneity in PLS model. Yeah. Now, if you see the second case, in second case, we are having the same model. This is find to be 0.3, this is 0.4, and this is 0.0. Now, if you run this model on these different groups, this 0 becomes minus zero point 0.7 and plus zero point 0.7, and this 0.4 is coming to be 0.7 and zero point 0.1. So that is another problem. So if you see this graph carefully, the problem that we are facing is that if you run the model, so we are talking about the model, not the measurement model, we are talking about the structural model. So in case of structural model, if you run the structural model in the two different segments, you will get the significant different results. So the hypothesis which you are accepting or rejecting in the complete data set, the hypothesis is wrong, all the conclusions are wrong, and you cannot generalize your conclusion if you have this kind of problem. So this is the uh, problem of unobserved heterogeneity. So in the previous class we have discussed so how the problem occurs in the measurement model, so that we analyze with the help of invariance. But in this case we are running the model in two different segments, and we found that the results and hypothesis testing are entirely different, right? So how to tackle with this problem? How to tackle this kind of heterogeneity? So this is the problem that we are going to discuss. Okay, so let's go. Okay, the concept of heterogeneity. So some of the important points which I want to discuss here. Now, researcher can obtain different parameter estimates when they consider differences among observation relative to when they overlook them. However, heterogeneity among observations is not necessarily captured by the variables that are preconceived by the researcher and specified by existing theory, as it exists beyond these previously identified variables. As a consequence, it is necessary to differentiate between two types of heterogeneity: observed heterogeneity, where when some subpopulations are defined a priori based on known variables such as gender, age group, income group, experience, like that, and there are you are required to analyze the unobserved heterogeneity when the subpopulation in the data are unknown. So that is the logic of capturing the unobserved heterogeneity. Observed heterogeneity is measured by the demographic profiles like gender, education, income level. So when you incorporate these variables, so it means you are capturing the observed heterogeneity. But in many cases, the unobserved heterogeneity are coming because of the psychology, because of the cognition, because of the perception, because of the other differences. So we have to find out that. And finding these heterogeneity is known as unobserved heterogeneity. So they define you a model. So I'm going to discuss that model. This model is known as POS. Yeah. So now the POS is starting from here. The before that they describe the common problems of the unobserved heterogeneity. So that is a different thing. Okay. Now what is POS? What is prediction oriented segmentation? So we have to understand these lines. For that we have to read this paragraph so that we can discuss on this. To overcome the identified methodological limitation of IBEX PLS and of the existing distance-based measures, PLS segmentation methods for uncovering unobserved heterogeneity, we introduce the POS method. Now, what POS is doing? Number one, It uses a PLS specific objective criteria to form homogeneous group that maximize the explained variance R square. Now the first point they say that we are dividing the data into different categories in such a way that the every group is homogeneous and the R square is maximum in different subgroups. Like for example, if a particular model, the R square is 50%, and the software will divide the data into two equal groups in such a way that R square of the one group is more than 70% and R square is second group is also more than 80%, like that. So overall R square is only 50%, but if you run the model in the different subgroups, the R square will be very high. Even this method is having one more facility to create the niche segments. So that facility was not available in Fimix, but POS is very good in identifying the is very small niche segments. So even you can find out these niche segments in the company. Niche segment means the habit of these people are unique. The habits of these people are unique, and it is very important to disclose them. So this is another power of the POS. It can identify the different niche segments in the data set. The third thing is the third observation is that okay, the readjusting approach. Now, if you see this, the later feature of PLS POS causes continuous improvement of the objective criteria through the iteration of the algorithm. That is known as hill climbing approach, and provides the ability to uncover very small niche segment. Okay. Now you may be thinking that what is this hill climbing approach? Hill climbing approach. So hill climbing approach is the approach when you are making the segmentation and assigning the different observations in such a way that you put a criteria that by adding a new observation, if R square increases, we take it. If R square don't increase, we don't take it. So this is the base of the algorithm. The software will develop in the to examine the segmentation. So they will divide the data set into two categories, and they divide the data set in such a way that if you add one observation in another category, the R square, if increases, then they will accept it. If R square will not increase, they will not accept it. So this kind of criteria they will follow in case of POS. And one more point that is very important in this point number 2. It includes a new distance measure that is appropriate for formative measures and heterogeneity within them. Okay. Now, what is the meaning of it? The meaning of this sentence is that uh, there are two types of measures in the model. One is the formative model, formative constructs, and second is the reflective constructs. So this paper claimed that the Fimix method is very good for analyzing the heterogeneity in the reflective measures, but POS is very good also in handling the formative measure too. So in case if you have formative plus reflective, then go for POS. If you have only uh, reflective measures, then you can apply Fimix. So that is the comparison between the PLS and the POS and the Fimix. Okay, so this is the theoretical background of these two methods. I think after that they come to the mathematical part, and that is not okay. So that I'm not explaining. Now we are coming to
कितने रुपए लेंगे? हाँ 120 नोटिस है ना?
ये कौन है?
चलो टोटल
मानसी?
बताओ ना सबको बना। ये 40 रुपए जमा कर जाए। हाँ नोटी के पैसे अलग अलग लेंगे। नहीं है एफिडेविट वो प्रोफेसर लिखवा रहे हैं आपको रेगुलर आना है और क्या क्या क्या
Mansi,
क्या
could you
क्या
please
क्या
mute yourself?
Mansi saying, please mute yourself.
वो टाइपिंग वाला कितना ले लेगा? एक पेज का मैटर 2 पेज का? एक पेज
We are doing it.
मैटर है हमारे पास।
Mansi saying, please mute.
लिखा हुआ है
सब्जी खरीदने का। ओके, मुझे लगता है लेक्चर सुनना और सब्जी खरीदना दोनों एक साथ चल रहा है। ओके, now we are basically comparing. So I just summarize what I said in this session, half an hour session. Whenever we examine the hypothesis, whenever we examine the theory, we never focus the presence of heterogeneity in the groups. So this is a problem, and this problem leads to the misleading results. So we have to divide the data set into different segments, and to check whether both are same or not. Both the segments are same or not. So both the segments should be similar with respect to measurement model, and both should be similar to the structural model, the hypothesis testing, and to capture the heterogeneity in the data set, we have to go for observed heterogeneity, and observed heterogeneity is normally captured by most of the people. But now the question is that how to capture the unobserved heterogeneity. So the topic is basically to capture to capture the unobserved heterogeneity. Okay. So let me share this screen again. I think there is a problem. Now, if we go to this paper, so this paper is actually talking about the unobserved heterogeneity with Phimics PLS. So the authors, this is Joy here and Ringal also. So they define the presence of what is unobserved heterogeneity. So this paper is very good in explaining how the unobserved heterogeneity will give you the misleading result. So you can see that. So these two papers will give you more clarity about the presence of unobserved heterogeneity and why it is important. So you just see this line. Failure to consider such heterogeneity can be threat to the validity of the PLSM result, leading to incorrect conclusions. So this is said by Baker, 2013 paper. So the earlier paper is Baker paper. Wrinkle. So this is called self-citation. Okay. Now, this assumption of relatively homogeneous data characteristics is often unrealistic. So this is the problem that almost every researcher is assuming. Okay, even if you read this line, see this line, PLSM applications usually analyze a full set of data, implicitly assuming that the data stem from a single homogeneous population. This assumption of relatively homogeneous data characteristics is often unrealistic. So this is the problem, that if you consider that your data is homogeneous, actually it is not homogeneous, it is the heterogeneous. So they give very good example here. Okay, they say that the model shown in figure number 1, in which customer satisfaction with product depends upon two popular dimensions. So this is just example. So customer satisfaction with a product Y depends upon two popular dimensions. Some are satisfied with the quality and some are satisfied with the price. So they say that the customers can be divided into two categories: quality conscious customers and the price conscious customers. But the problem is that we are not incorporating these type of behavior in the model. So this example will make you more clear about the unobserved heterogeneity. So the model shown in figure 1, in which customer satisfaction with a product Y3 depends upon the two perpetual dimensions, quality and the price. Yeah. So they say that this fact, right, illustrate the problem stemming from failure to treat heterogeneity in the context of PLSM. Suppose that there are two segments of equal size. Group 1 is quality conscious, and whereas group 2 is price conscious. But the problem is that this behavior is not captured by the hypothesis testing, as indicated by different segment specific path coefficient. More specifically, the path of quality Y1 is much higher in group number 1 than in group number 2. So they say that if we divide the data into two equal parts, so we found that the path coefficient in quality is highly significant in one segment and a second lower in case of second segment, right? Similarly, with an absolute difference of 0.40, the path for price to satisfaction is much higher in group number 2 compared to group number 3. So now they say that if you capture this behavior, quality conscious behavior and price conscious behavior in the two groups, you will find out the two different beta in two different groups. So uh, now what is the duty of the researcher? The researcher should identify the unobserved segments, study these unobserved segments, and explain the difference in the behavior of these unobserved segments and add value to the theory. So this is the objective of doing the unobserved heterogeneity segmentation. So similarly, there are many examples. So they further said the heterogeneity in the data can be observed or unobserved when differences between two or more data related to the observed characters such as gender, age, and country. This is called observed heterogeneity. So first of all, you have to add as many as reasons of observed heterogeneity like gender, age, country, origin heterogeneity. But apart from that, also you have to uh, check for unobserved heterogeneity. Okay. Now they say that to account for unobserved heterogeneity, researchers have routinely used clustering techniques such as k-mean or indicator data or latent approach. But here the software is providing you another approach which is based on distance and the prediction. Distance and the prediction. So, okay, so the first technique they are providing is the Femix, and the second technique they are providing is the pause. So now I am going to the pause model because Femix we have done in the previous session. Now I am going to pause. So let me, okay, save this. Okay, now we are moving to the presentation of the or how to do it in the PLS. Now, a few questions which I want to ask at this time is that what is the difference between observed heterogeneity and unobserved heterogeneity? I think you are clear with it. Second, how many methods are available to capture the unobserved heterogeneity in PLS model? Answer is Fimix, and second is POS. Third, how the unobserved heterogeneity will lead to the problem? Answer is that uh, basically there is a difference in the behavior of the people, and this difference is not captured by the model. So the unobserved heterogeneity will give more clarity, or you can add value to the theory by adding the more different kind of behavior in the employees or the customers. If I ask you the simple question, because all of you are working somewhere, is because whenever management come with the a new policy, is the response of every employee is same?
Never, sir.
No, never. Because there is a difference in the behavior. Now the question is that how to capture that behavior. That is the problem. So that example I'm showing in this example. And how what now the basic another question is that, because I'm going to demonstrate the oriented segmentation. So how the POS is different from the Fimix. So that is also important. So I have 3 points here. Number one, Fimix is very good in reflective models, and POS is very good in both reflective as well as formative. So you can say POS is the let me explain the difference between Fimix and the POS first. Fimix method is very good in reflective, or if we say there is a high level of multicollinearity. If you have very high level of multicollinearity in the items, then Fimix play a very important role. But in case if the multicollinearity is not there, that or the construct is formative in nature, then POS is very good. POS is not only very good in the formative, it is also very good in reflective. So in reflective, both are good, but in formative, only POS is good. So that is the one difference. So the implication is very simple. So if your model is having any formative construct, so don't use Fimix, go for POS. The second difference is that in morning we have found that the sample size of the different segments are comparable. The sample size of different segments are comparable, but POS is having the capability of finding out very small segments, small segments. So like for example, in a company, 2% people are highly buttering type people. चमचागिरी जो होती है ना, चमचागिरी वो 2% ही होते बहुत कम है, but they are already there. So the POS can also identify these kind of people. So they are 2%, 3%, 4%, but POS is able to identify these people also. So this is a very niche kind of segment, right? So Fimix is giving you the comparable segments, but POS is giving you the niche segment. So this is the second strength of the predicted oriented segmentation. The third is the Fimix is very good in the measurement model, not very good in the structural model, but POS is very good in both. The predicted oriented segmentation is very good in the measurement model, also very good in the structural model. So this is the third strength of POS. Now, what is the problem in POS? Number one, in Fimix, we are having the selection criteria, and these selection criteria will help you in identifying the ideal number of segments. But in POS, we don't have any segmentation. So we don't have any the method of segmentation. So the author says that you have to make your common sense, use your common sense. And with the help of the common sense, you go for the trial and error method, and whatever results you feel that it is suitable, go for that. Now I'm giving you one example. Suppose I believe that the employees can be divided into two segments. So then I will give a command to the software that I want to make two segments, and make two segments and check the results. Then I analyze the results. Then I go for the three segments, four segments, five segments, and so on. So, and because POS is having a strength to give me the niche segments in the data set. So if they are meaningful, you can go with that number of segment. Otherwise, so it is a subjective criteria actually. So it is a subjective criteria that how many segments you want to make out of the data set. Because we don't have any formula. In Fimix, we are having the formula, and the formula will tell you that what is the maximum number of segment, what could be the optimum number of segment, but in POS, we don't have that formula. The last and the important thing is that after that, we will go to the practice hands-on part. The last part is that actually all of us want to make those models where explanatory power as well as prediction power is very high. So sometimes we found that the explanatory power is not very high, and the scholar will face a problem. I'm giving you one example. So one of the scholar was giving presentation in one of the famous university in Delhi, and the R square of the model, it's a PLS, it was the PLS model, and in PLS model, so in PLS model, the R square was 45%. I'm just sharing a real story with you. After that, I will go to PLS software. I'm not showing any PPT this time. Okay, so just listen a story. So the scholar was presenting presenting the thesis, pre-thesis viva, and the R square of the PLS model was 45%. The panel member says, your R square is very low, so we are not going to accept your model. We are not going to accept your model, so we are cancelling your PhD thesis. So then the research scholar called me, sir, this is the problem. What should I do? So actually, because as a statistician, we know that how to increase the R square, that is not a very big problem. So we did three things. Number one, we searched the literature review first, that in 50 papers, what is the value of R square? So we found that in 50 top quality papers, 45 papers have the R square more than 50%. So this is the knowledge we got from this exercise. Only very few papers have the R square less than 50%. So, so literature support was not enough to support R square of 45%. The second method is that we can convert the PLS model into a regression model and can find out the outliers. And we are having a method called Cook's distance, and that method is helpful, very, very helpful in identifying the outliers, removing the outliers, and increasing the R square. But now I'm telling you one more thing. This POS method will also solve that problem, because this method will divide the data into different parts, and you may not believe that for each part the R square is the highest. The R square is higher than the average R square. So this is the most powerful strength of the POS. So now I'm going to the data set and the PLS software, and I'm showing you practically how to do it. So let me share this screen. Okay, so now I am going to exercise called change management. Okay, so this is the data and a model I take from a PhD thesis. So this is the data of a PhD scholar, but because the PhD is already awarded, so I'm using it. So before going to the model, applying the model, let's make it reflective. Now, this is reflective, this is reflective, reflective, and reflective. So first of all, I want to go for CTA to check whether all the constructs are formative or reflective. Because if you have any formative construct, so POS is very, very good for that. Now you can see that if I go to the benefit of total change, most of the p values are more than 0.05, so it is reflective. Change p values reflective, refreezing reflective, unfreezing, so 1, 2, 3, so it is formative. So you can see that here we are having the formative problem. So I convert this model into formative. So I am having formative model as well as reflective model. So I am using a mixed model. So let me remove the other files. Yeah. So I'm going to apply the pause in this model where for one of the construct is formative and others are reflective. So go to calculate and go to POS. You can see that POS prediction oriented segmentation. Okay. Now the question is that how many segment I should make? 2, 3, 4, 5, right? So we are having problem in this. So the author is silent on this. So there is no clear-cut formula in identifying that how many segments we should make. So let me take the 2 segments initially. So I will go for 2, 3, 4. 3 experiment I will do in this session. And all other things I'm not changing anything. So going to start calculation directly and not making any change. By default, I'm taking all. Now the software is running it and I have to wait for some time. Because pause is a slightly lengthy procedure, so software will say take some time. So 4% done. Meanwhile, the calculation is going on. If you have any query, you can ask. Because POS is a big algorithm, so it is quite slow. But we have to complete it, so we have to wait. Yeah. So the result is coming. Now this is POS segment 1. This is POS segment 2. And this is original. So now I have to compare these 2 segments. So I'm opening a Excel file and using this for comparison. So I'm taking a new sheet and writing here. So comparing the segments, extracted from POS method. Okay, now let me see the result. So I'm taking the Excel. So first of all, I'm comparing the path coefficient. I'm comparing the path coefficient first. So this is the segment number 1 Excel format, and you just copy that. So this is the dependent variable. This is my independent variables, and for original, this is I think segment 1. So segment 1, I removing this. So for segment 1, so during the change, this is negative, otherwise they are positive. So before change, the contribution on performance is positive. After change, the impact on organization performance is positive, but these people are slightly resistant of change during the change. So you know that there are 3 stages of change management: before change, after change, or this is called refreezing and freezing, and during the change. So this is the beta I'm getting from the segmentation number 1. Now I'm going to the segment number 2. Segment number 2, copy it, and so paste here, and I'm taking all the 3 beta here. So this is segment number 2. Segment number 2. So now you can see that segment number 2 are very, very effective during the change, but not effective before and after. Not effective before and after. It is very poor. It is very poor, right? So now we are going to the overall all. So let's see what is the all value. So you can go to the original and copy these values. So this is my original data. So in original data, all are found to be positive and significant, but for the different segments, the value is different. Now the question is that what name you want to give to segment number 1 and segment number 2. So because naming is very important at this stage, how you name segment number 1 and segment number 2. Like for example, in the paper, the author named the segment as quality conscious and the pride conscious. So who are these people? So let me say segment number 2, before change, they are not very productive. After the change, they are not very productive, but during the change they are very productive. तो इस तरह के लोगों को आप क्या नाम दोगे जो ना तो चेंज से पहले प्रोडक्टिव होते हैं ना चेंज के बाद प्रोडक्टिव होते हैं, बट ड्यूरिंग द चेंज दे आर वेरी प्रोडक्टिव. Actually, these are the people who assure the management that we are with you and we will support you during the change, but they are not very supported before and after. So you have to give some name to this. So those who are from HR, they can suggest any name and I can put it. So otherwise, I will put my name. So I know that they are very clever people. So they don't work before, they don't work after, but they show that they are cooperative during the change. So normally every person resists the change, but these are the people who don't resist the change. They love the change, but no, after and before they are inactive. But these are normal people. Normal means they are routine people. They are productive before the change. They are productive after the change. But during the change, they are not as productive as other people. So they are the old people like that. Some old people change. They are not productive during the change because they are learning all the things. So now the point is that you have to give the name to the segments. So naming of the segment is very important at this stage. The reason being that you have to add value to the theory. So we are saying that there are two kind of people. So one is the intelligent people or clever people or smart people. So the smart word is better word. So smart people are those people who always show during the change that they are proactive, but after and before they are normal. And the normal people are very good in before and after, but they are facing problem during the change. So you have to give some name to the segments. And it is a subjective issue, so I am not focusing on this, because anybody who is having good theory on the topic, only then he can give the name. Okay, so we have we compared basically the different segments with respect to path coefficient. So it is path coefficient. Okay, now let's see other aspect. Let's compare the R square. R square. So what is the R square of segment number 1, segment number 2, and all? So now go to the R square quality criteria, and you can see that the original R square is 60%. So I write here the original R square is 60%, and the segmentation segment 1 R square is 81%, 83%, 81, 8336. So this is 81% and 83.6% R square. Now you see the R square, the change in the R square because of the segmentation, right? So originally the R square is only 60%, but R square of the first group is 80%, 81%, and the R square of the second group is 83%. So this is slightly amazing part, right? So the benefit of doing the pause segmentation is that this is the most important point which I want to write here. Most important contribution of pause is increase in R square for different segments. So this is the most important contribution of this POS segment, right? So this is slightly amazing thing which I found in the PLS software. So you can show that for normal people, smart people, but actually this is subjective, so I don't comment on that. The R square is very high. So that is the another contribution. Now, if you go back and okay, so this is not a good. You can also compare the total effect. You can also, but because we are not having any mediation and moderation, so path coefficient and the total effect are the same. Indirect effect is also same. We don't have any mediating variable. Outer loading, if you want to compare, you can compare, but it will take a lot of time, so I will not comparing it. So you can check that for segmentation 1, what is the loadings for segment 2, what is the loadings, like that. So this is original. If we compare this, all values are more than 0.7. If we compare this, all values are more than 0.7. If I compare for segment 1, all values are more than 0.7. So I have no problem in this. Segment assignment, yeah. Now I want to go for segmentation. So segment size, let's compare the segment size. First size is comparable 175 and 212. That is quite comparable. 175 and 212. So let's write here. So in segment number 1, the number of people is 175 and this is 202. So we are not having any niche segment till in segment 2. Okay. So in this way, we can compare the R square, the path coefficient, and basically we are comparing the structural model. Similarly, we can check for the path, the measurement model. So I am showing you how to do that. So first of all, you have to go for segment assignment. The segment assignment comes here. I am taking this segment. So first person goes to the second group, second person goes to the second group, fourth person second to the first group, like that. So just click on it and go for the data set, change management. Okay. So in this data set, so I am deleting it. Even I am deleting this also. Yeah. So I created the segmentation. This is called POS 2 segment. POS 2 segment. So here there are 2 segments and we have designation also. We have age group also. Yeah. Now, second thing is that I will compare for 3 groups. So before that, let me take this data set into the software because I make changes in the data set. Okay, so I am working on this data set. First of all, I have to delete it. And I'm taking the new data set from here. And let me check, is the changes is accommodated? Yes. So now we are having POS 2 segmentation in the data set. Go to the model. And now I'm going to check the consistent PLS. Okay, data is groups is not here. So first of all, we make the groups. Generate data group. So group is POS segment. So there are 2 segments and we have to find out the variable here. So POS, this is the variable. Okay. Now software is saying that there are 2 segments. One is 1. So 1 are the normal people. So I am saying that normal people. And the second segment is the smart people. So these are the name I provided to the segments. So normal employees, smart employees, and now go to the model and go for consistent PLS. And I'm comparing these data groups, normal with smart. You can check data groups, start calculation. So here I have to check the model invariance in the 2 groups. Model invariance in the 2 groups. So first of all, I will check for the construct reliability. For complete model, I have no problem. The perfect. Okay. So Cronberg alpha, good, rho, good, composite reliability, good, AVE, good, matrix is fine. So I don't have any problem in Cronberg alpha because it is a formative. So we are not having the answer. And because in case of formative, we cannot, we are not calculating the Cronberg alpha, composite reliability and the variance expected. We only calculated for the reflective measures. So all good, and in normal all good, in smart all good. So I can say in segment 1 and 2, the reliability, analysis, okay, and okay. In the paper, you have to show the values, but I am not showing the values for. I'm just saying that they all are good, all are support, no problem. The convergent validity is okay, and okay. So I found that there is no problem in reliability analysis and all. And then I have the discriminant validity. So in discriminant validity, let's see. So go for the estimated ratio problem. Incomplete, there is no problem. In normal, there is problem. In smart, there is a problem. So not equal. My conclusion is, let's make the conclusion here. So we can write this similar, dissimilar. So they have dissimilar discriminant validity. So measurement invariance is not exist because of the discriminant validity problem. Otherwise, in reliability and convergent validity, we don't have any problem. Okay. So and this problem is also not very serious, because by maybe if we have more data set, then this problem will not come. Okay. This is basically the invariance test. So I can write here. This is the measurement model invariance test. Okay. And now after that, we are going to another testing the moderation effect. Moderation MGA effect. So we have to compare this also. Now I'm going to the next MGA test. So just cross all, go to calculate, go for MGA, and we are comparing with the normal and the start, calculate. Now we are comparing the whether the but I know that they are different, so you can see that all are different, and so we can report here. Okay, so you can see that this is the beta normal minus smart. So we can say this is the path coefficient normal. So I just write n minus s, normal minus start. So it is minus, it means the smart people have this more negative here, more beta than this. In all other cases, the normal people have more beta than this. Okay, this value is not required, p value, because it is significant. Okay, now I can say, now here also we have to write the t value, and conclusion is significant moderation effect. So my conclusion here is significant moderation effect exists. So this is my conclusion about the segmentation. So we are doing three things here: comparing the quality criteria, comparing the measurement model, and comparing the moderation. So these three things we need to report while doing POS. Okay. So the same process we can repeat for the three segments, and four segments, and five segments. And this is actually the POS. The POS is just like this. Similarly, I can go for the three segments. So what is left here? Let's let me delete it. Now we can go for the three segment case, and the software will open it in few minutes. Actually, we can go for three segment, four segment, five segments. So it depends upon the size of the data set. So let's complete the process of for three segment also. If you see this Baker ETL 2013 paper, so that paper which I am showing you is the basic of this technique. So if you want to understand the pause technique, you have to read this paper in detail. So it is taking time in 3 segments.
This is the first time, sir, the software is feeling tired, I suppose.
No. It is a routine time.
Okay.
Yeah, it is a routine time. So every time if we do, so it will take, because this algorithm is a quite big algorithm, and if you increase the sample size, it will definitely take time. So it is the average time the software is taking.
Okay.
ये time consuming है ही actually. Maximum 1 or 2 minutes the software will take and it will give the results. और मैं इसीलिए 4 sample वाला नहीं करूँगा because I know that the software will take more time in that case. Okay, now let's take the 3 groups. First of all, compare the segment size 170, 132, 85. So it is also comparable samples, and still I am not looking for a niche sample. Sometimes what happens, one of the group is only having 10 people, 15 people. So that group is very interesting group actually. So I am looking for that kind of group, but this sample size is also comparable. And if I go to the path coefficient, because I have to give the name to these groups on the basis of the path coefficient, so that's why I have to take, original path we all know. So segment 1, let's see. So we take the, here, where is the, yeah, so now we are calculating for the segment 1, segment 2, and segment 3. So now we are having 3 segments. So we will compare on the basis of the 3 segments. So let's paste here. The path coefficient of segment 1 is this. And first of all, let me take all the segments and then I will give the name to the segments. Segment number 2, Excel, if you click on the Excel format and just paste here, this is the beta for segment 2. And after that, I will go for segment number 3. Segment number 3, the beta is this. And on the basis of this beta, I have to give the name to these 3 segments. So first people, so let me check what are the variables. So during change, the first group is not very positive. Refreezing, they are very, very active. Unfreezing means after change and before change, this group is contributing a lot, but during the change, they are not contributing. So I am calling it the normal employees or change resistance employees. You can also call that. So those who don't like change. And this is, they are super active, hyperactive in the change, but not before and after. So to some extent, they are also after, in before they are negative. So these people I call, they are smart people. And these people are still smart, but they are also very, very active in after change. Unfreezing, I think it is before change, after change, they are positive. After change, no, before change and during change, they are positive, but after change, they are negative. So they are super smart. So I can say, so they are super smart. So now I'm making three groups: normal people, smart people, and super smart people. They are positive before change, they are positive during change, but after the change, they are just like, okay, now the ab to ho gaya, that's it. So you can name the segments like this. So naming the segment is very important. Explaining the behavior is very important. Now we are going to check the R square. R square we can check here. And if I see the R square of first is 89%, 87%, 90%. No, 83, 90. Okay, let me take here. Take the value. So R square is found to be this. The three groups have very high level of R square. So that's why, because of this high level of R square, we can say the pause method divide the data in such a way that R square for each segment is super high. This is because of this property, the method is known as POS method, predicted orientation segmentation method. So here we are doing the segmentation in such a way that a normal R square, this is the normal R square, and normal R square is is increasing to 87%, 91%, 92% in. So actually I feel this is much better, because in previously in segmentation 1, the R square is only 81% and 83%, so slightly lower than this case. Yeah, but however, in this case, in if we divide the data in three segments, so I can say the R square is much better. Now we are having more clear behavior of different segmentation with respect to change management, right? So that's why, in my perspective, I can say the three segment solution is better solution as compared to two segment solution, right? After that, we can go for the reliability, convergent, validity, and all other things you can do only when you make the segmentation in the data set, because we are not having any other values here. So what you have to do, you have to go for the segment assignment, Excel format, and now add the data here. So this is my segmentation, POS 3 segment, or now we are having 1 to 3. So save it, and now take the data from the raw data to the Excel data, which is the data set change management. So do we have any? We have three segmentation values. Okay, go to the model, then go to the हम क्या करना है पहले हमें PLS consistent. So we have to go to PLS consistent, but before that I have to define the data, define the groups, define the data groups. This is called POS3 segmentation. The name of the variable is POS3 segments. Okay. Now I go to the segment 1, 2, 3. So we can go segment 1. Segment 1. Similarly, segment 2 is named as so this is my segmentation 2, and similarly I will click for segmentation number 3. So this is my segment 3. So there are three segments, segment 1, 2 and 3. Now we are going to comparing their reliability and validity from there. Start calculation. So one thing still I missed, that I have to calculate PLS with comparing the data groups calculation. Because comparing the data group is important, otherwise you cannot compare the data. So let's go for the segment number 1, reliability, validity, all clear. Segment 2, all clear. Segment 3, all clear. So, okay, now segment 3, we have a problem. Segment 3, we have a problem. So we have to show like this. Reliability analysis for segment 1, it is okay. And segment 2 is okay. Segment 3 is okay. Conversion validity, okay. Okay. This set not satisfied. Similarly, this condition is okay. Okay. Discount validity तो हमने check नहीं किया अभी. So we have to check the discount validity also. And HTMT segment number 1 not clear. Subject number 2 not clear. Subject number 3 clear. So we can write it is subject number, segmentation number 1, 2, 3, 1, 2, 3. So I think it is not clear, not or satisfied. Not satisfied. And this condition is okay. So we have to write the where these segments are different. You have to report that which segments are similar, which segments are not similar. Similarly, we can check for the moderation effects. So command I am showing you of the moderation effects. You just go to the model, go for MGA analysis, compare segment 1 with 2, 3, 4 each other, and okay. And I'm hoping to get the results that they are different. Because R square is different, so they should be different in path coefficient. So moderation effect, I know that they are found to be significant. So you can see that the except one, all p values are significant. So it means there exists significant moderation effect. So I can comment here. So significant moderation effect found. So you can find out three things: comparing the R square and the path coefficient, comparing the convergent and discount validity, and comparing the moderation. So after this part, moderation, now it is fine. It is so you have shown the POLS with respect to different data groups. After that, you have to do one more thing, that is called cluster profiling. Okay, let's close it. Okay. So this is our data set. So we are having 3 segments and 2 segments. I am saving the data set and open this data set in SPSS. So what I'm doing the cluster profiling. So cluster profiling comes after this. I have to import the data set. You can import the data set only when the data is closed. So I save it and closed. I go to the file, import data, CSV. This is the data set I am going to work with. Okay. Now SPSS will open. So I have to do the cross tabulation between designation and segment 2 3. Let's say for the segment 2 also. Okay, so if you see the chi-square value not found to be significant, no, I have to give some more commands. Analyze, descriptive, cross tab. So columns comes in 3 and this is fine. In cells, go to expected. In statistics, go to chi-square. And that's it. Click OK. So now you will get the result.
Click OK.
Okay. So first of all, we have to see the chi-square not significant, chi-square not significant. So it means we cannot say that these segments are related to the designation or these segments are related to the any other category. So I think which category we take? Designation. So I take another category also. Yeah. So we have one more category, age. So now I think we can do it. So there are 4 combinations. This is not significant. This is not significant. This is not significant. Not significant. So this is also not significant. So actually we cannot say that these people or the people in any segment belong to some special category. So we cannot say that. Actually, I want to see, is there any, is it possible that one segment belong to the female, more female, or one segment belong to more males? So cluster matching or cluster profiling you can also do with the help of comparing the different demographic profiles and with the different segmentation you drawn from the POS method. So this step is also very important sometimes to find out which kind of people comes in segment number 1 and which kind of people comes in segment number 2. So that is also important for writing the paper. So I think we have done everything in POS. Nothing is left. So I demonstrated you that how to compare POS. So we have to compare in 4 aspects: path coefficient and R square. This is called the prediction, comparison of the prediction or the model quality, prediction of the measurement model, prediction or comparing the MGA. So these 4 comparison you have to make to whenever you are running the POS. But the most important objective of POS is to identify the segments and naming the segments and find out how they are different to each other. So if you can give a proper name to the different segments, so I think you are adding theory in the research, you are contributing to the theory in the research. So that is a very good idea of increasing the quality of the paper. So that's it from my side, because nothing left in the pause after that. And so I am open to the query. If any query is there, please ask. So anything which you feel is left, so I'm open to that.
Sir, I want to ask a question.
Yes, ma'am.
Sir, what could be the broad areas where we can use this pause technique? If you can just highlight few of the broad areas, that would be great.
Yeah. Actually, the when you want to focus on the behavioral aspect, right? If we are saying that the behavior of the people are different or not, like for example, the buying behavior, the employee behavior, or customer behavior, patient behavior. So behavioral, when you want to identify the reason of heterogeneity in the behavior, right? Then you can apply the pause. So normally we apply pause in consumer behavior studies, and I have seen also in the employee behavior studies. So employee behavior, customer behavior are the two things which is coming in my mind. And you can also apply on the academician behavior, then student behavior. So like that.
Okay, thank you, sir.
Is there anyone who wants to ask any question to Dr. Ajay Kumar Chauhan? Anyone? I don't think, sir, that they have any questions right now. So let them practice. We'll meet again tomorrow with Dr. Chauhan. And meanwhile, if you have any kind of query, you can ask tomorrow also, because we have 2 sessions of Dr. Tomorrow also. Fine. So we'll be meeting tomorrow at 9 a.m. Okay, sir. We can call it a day.
Sure.
Okay. Take care. Please, participants, please fill the feedback form for the session, and after you're done, you all can leave.
ये हो गया आपसे रहता पता नहीं चला सच